Testing.
Work, doctor.
Okay, Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza shi'ta sahla. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Can you hear me?
Good morning, Doctor.
Morning, doctor.
Morning, Doctor.
Okay, right. So, okay, for today we are going to learn new topic. Okay, new topic, which is moment in 2D. Okay, previously you have learned about particles. Okay, and this time round you will learn about rigid body. So, particle is very simple. I can say that a very simple body. Okay, but this one rigid body we have to consider all dimension. Okay, the length for example, and the simplest one is the length in this chapter, in this lecture. Okay, so this is the thing that you will learn for today. Okay, the first one is to analyze rigid body. Okay, to analyze the rigid body. The second thing is the moment. You will learn about a moment. Okay, a moment. The other word is torsion. Okay, moment of a force about a point in 2D. So you will learn on how to calculate torsion. Okay, torsion. Let's say you are moving a rigid body like this. You will calculate how many moment about a point. And next one is Vanden theorem. Okay, you will learn what is Vanden theorem. And number 4 is principle of transmissibility. And last is the example and exercise. Okay, so this is the analysis of rigid body. Okay, a basic thing about rigid body. In reality, forces at different points of application. You can see in our body. Okay, in our body, there are many forces involved. Okay, there are many forces involved. The external forces, let's say this is my hand. You can we can imagine, actually we can imagine the internal forces acting throughout the hand. The forces can be from the muscle, the forces can be from the weight, the forces can be from the ligament, so on. Okay, and let's say I touching my I push my hand like this, there is an external force. Okay, there are many forces in different points. Like this point, external, internal, we can see a lot of ligament, tendon, and so on. Okay, so the size of this hand, okay, this body, we call it body, will have to be taken into consideration. So the length, and also the thickness, for example, should be considered. Okay, and assume the body to be rigid. Yes, of course, we are assuming the body, the hand, is rigid. It cannot be moved. Okay, we assume it rigid, but in reality, it can be moved. Okay, and bear in mind that we are learning static, so we assuming this body is rigid, does not deform as well. Okay, does not deform, meaning that when I push the body, it will not be deformed. Okay, will be static. Okay, and the last one is each of the forces acting on a rigid body can impart a motion of translation, rotation, or both. Okay, if you put some forces, okay, like this, acting to my another hand, okay, it can be impart a motion of translation. For example, translate into another motion like this. Okay, or rotation. Okay, you will learn later on. okay, about the translation and rotation. Okay, just a recap about the external and internal forces. Okay, forces acted on rigid body. We do have two different forces. The first one is external forces, which is action of other bodies. Okay, action like my other finger here. Action. Okay, this is external force causing it to move or ensure that it remains at rest. Okay, for this case, the external force causing this hand to move. Okay, to move. Okay, for example, at rest, maybe the external force is friction, for example. Okay, friction. Okay, friction. On the body under consideration. Okay, that one is external force. For the internal forces, forces that hold particles forming the rigid body together. Okay, so let's say this is the same example. Okay, same example. So forces, internal forces here, ligament, tendon, muscle, bone. Okay, whole particles. Particles mean the whole body. The whole body forming the rigid body together, meaning that the internal forces inside the hand is forming the rigid body. Okay, for rigid body with several parts, the forces holding each part together. So let's say I have this joint, elbow joint. Okay, ulnar radius and also humerus bone. Okay, ulnar radius, humerus bone. So we do have one joint here, which is elbow joint. So there are two parts, the ulnar radius part and then the humerus part. Okay, so for rigid body with several parts, the forces holding each together. So the forces, the forces between these two parts, okay, in between the elbow joint, okay, holding each part. So meaning that the internal forces can hold the different parts together. Okay, so we will consider external forces in this section. Internal forces will be analyzed later. Okay, in this 2D moment, we will only consider external force. Okay, external force. Okay, this is the moment. This is the moment. Moment of a force about a point. So when we calculate a moment, we do have to point. We do have to select a point. Okay, we do have to select a point. Okay, so the moment of force about a point is defined by this equation. Okay, m moment about point B. So we put B point. M moment of a force about a point D. Okay, equal to F times with D. F for force, D for distance. Okay, all right. So the direction of moment is clockwise. Clockwise. Okay, and means that the clockwise is negative. Okay, or counterclockwise, CCW is positive. Okay, so note that the moment of force about point B does not depend on point A. Yes, of course, because we are referring point B only, we are calculating, we are finding a moment about a force, a moment of a force about point B only. Okay, and we not considering point A. Okay, this is what the sentence means. Does not depend on a point A, but on the line of action of force. But the line should be here, perpendicular to the line of force. Okay, this is the line of force. Okay, this is the line of force. And the D should be perpendicular from the line of force to the point B. Okay. All right. So moment of force again. A force F is acting on a point A of a rigid body. Okay. What is the effect of this force on point B? So basically, if you do have this first rigid body with external force F, okay, with angle there, okay, you can translate this rigid body, equal to this right rigid body. Okay, so the useful of moment, we can do a translation. Like I I show to you just now, okay, we can impart a motion of translation or rotation, okay. So from the original rigid body like this, okay, with additional external force acting at point A, okay, you can translate using a moment, okay, into this rigid body, the additional, I mean the second rigid body on your right, okay, on your right, with a moment, okay, on a point B and a force, okay, from point B as well, okay. Some cases you have to translate this following according to the moment principle, okay. Okay, this is the Veninen theorem. Veninen theorem. So far, so good. Before I proceed to the next, is there any question? Okay, if no question, I proceed to the next slide. Okay, Venenen theorem, the moment of a force, okay, the moment of force, okay, about a point is equivalent okay, to the summation of the moments of the force components about that point. Do you understand this sentence?
Motion resultant.
No? Anyone? Do you understand the theory, the theorem?
Means the component here, doctor. X and Y.
On what component? What does it mean?
At the force in the point, we find the component, I think, or
Okay, okay, very close to the correct answer. Is there any idea from others? I just want to have two ways communication. So I just want to hear a voice from you. So you can, yeah, you can say anything that you understand from this theorem. There is no wrong and right answer. Anyone? What you can understand from this theorem? Okay, there are two different situation here. Anyone? 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 Come on, guys.
Doctor,
Yes.
the summation of forces equal the momentum when we multiply with the radius.
Aha. Not really correct. Not really correct. But yeah, thank you for giving idea. So basically, let me explain. Basically, if you still remember this equation, okay, we do have this equation, okay. We have this general equation of moment. So if you look at the picture, you have one single D, which is from A, not from A, but from the line of action. This is the line of action. From the line of action to the B, and the line should be perpendicular to the line of action. This D should be perpendicular to the line of action. Okay, this is the general equation. Okay, the Vananen said, okay, the moment of a force about a point, okay, which is M, okay, which is M. The moment of force about a point is equivalent to the summation. Okay, so we can say that this moment, okay, this m, okay, is equivalent, meaning that similar, same, to the summation of moment of the force component about that point. So we can see that like this, component x and y. Okay, so this is the thing that Vananen said. Okay, the moment of a force, it is from the F times D. Okay, it is similar, equivalent to the summation of moment. The summation of moment. Okay, of the force component. So we do have x component, we do have y component. So this is the meaning of Vananen theorem. Okay, do you get it? Guys, do you get it? Okay, only one answer
Yes,
to.
doctor.
Yes, doctor.
Okay, so let me explain further. So if you have this rigid body with a moment equation, okay, you have to use this D, okay, this D. Okay, if let's say you following the Vananen theorem, okay, you don't need to have this D. You have to introduce another D, another distance. Okay, so Vananen theorem said that you can resolve the component. You can resolve the force into a component. Okay, you can resolve like this: Fx, Fy. Okay, right? So you have to calculate individual moment. Okay, individual moment meaning z in the component. So let's say you are considering x component. So x component, the d is here. Let's say I put it d y lah, because x, y, z. D is y, d is x. Okay. If I put this definition as this. Okay. So d is dy. Okay. And then d is dy. And then the component of Fy, okay, and the D should be from the point B and the line of action, and must be perpendicular like this. And this is the dx. Okay, so if you have these two components, you have to follow Vananen theorem, which is the moment should be a summation of forces. Okay, okay, the summation of moment of force component about that point. Okay, so moment about this point should be like this: fx time with dy plus fy time with dx. Okay, this is the meaning of Vernon theorem. If you want to try, you can try both equation, this one, number one, and number two. You will get similar answer actually. You will get similar answer. So this is the meaning of Vernon theorem. Okay, do you understand?
Yes, doctor. Clear.
Okay, great. So in many cases, you cannot use this D. It is difficult actually. You can use, but somehow some student, okay, cannot imagine the triangle, because you have to introduce another triangle like this to find the D. Okay, if you are very expert in mathematics, you are very expert in sine, cos, tangent, etc., you can use this triangle to find D. Okay, but somehow to simplify the solution, we have to use Vananen theorem. So easier to get dy and easier to get dx straight away. Okay, you will go through the exercise later on and you will see how is the solution. Okay, so Vananen theorem done. So we move to the example. Are you okay, guys? Okay, so let's move to the example first. Okay, we do have many examples in this lecture. Okay, so the first example, determine the moment of the 1000 Newton force about point B by, okay, definition of moment. Okay, number 2, resolving the force into its components. So definition of moment meaning that you have to use general equation, which is M equal to FD. Okay, M equal to FD. Okay, definition of moment. The second thing is the resolving the force into its components. So you have to use the Varanen theorem to solve this second equation. Okay, let's say like this. Okay, so the first one, definition of moment. For definition of moment, of course, it is a tricky. Some student mistake always. Okay, so because of the distance, so basically you have to draw a line of action like this. Okay, and then we estimate, we assume that D should be like this, for example. Yeah, for example, it can be from here to here as well. Okay, the D. But in this case, we assume it any way that you like. Okay, anyway. So in this example, okay, in this example, we're assuming that D is this line. The D is in this line, perpendicular. Okay, perpendicular. We assume we cannot give the correct answer at the moment because you have to do some calculation, measurement, and so on. But in this case, we assuming. Okay, so D is this one. And then if you want to find the D, okay, you have to introduce a triangle like this. Okay, a triangle like this. Okay, so if you are using definition of moment to calculate the moment, you have to make sure that you expert in trigonometry. Okay, in trigonometry. So this is the idea. Okay, definition of moment. Okay, you introduce D there. Okay, with additional information of line of action. Okay, this is the line of action. This is the line of action dot 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 until a force line. Okay, and this is the D. Okay, and then this is the line from B to A. Okay, so why we introduce this line? Because we want to find the D using trigonometry. Okay, so if you use trigonometry, okay, you will have this some solution. Okay, so if you have to find some angle first. Okay, you have to find some distance first. Okay, from A to B, we can straight away find the distance using theorem Pythagoras theorem. Okay, A to B. Okay, line AB. So using theorem Pythagoras, okay, you will get 0.5. Okay, 0.5 for AB line. Okay, so we do have, let me write this thing, 0.5. Okay, and so the other thing is that the known. Okay, if you want to use trigo, you have to find this angle or this angle. Okay, this angle. But in this case, we have the solution show you to find this angle. Okay, to find this angle, which is using sine equation. Okay, sine equation. Okay, all right. So by using that, you will get straight away the angle of BAF. Okay, 30 degree plus tangent 0.4 over 0.3 equal to 83.13. Okay, all right. Do you get the idea on how to find the angle of BAF?
Doctor, it should be negative.
Sorry?
Because it's it should be negative because it's clockwise.
Hey, this one is not moment, lah.
Okay. Okay, doctor.
Still not moment. We are finding the angle. Oh, you mean the final answer, is it? So we are not reaching that point yet. So I'm explaining
yes,
about
doctor.
I'm explaining about the angle. Okay. So if you can see the 30 degree is from here, okay, so you have additional here, okay, so this one, this angle, let's say I put it theta 1 lah, equal to inverse tangent, okay, inverse tangent 0.4 over 0.3 lah, okay, using trigonometry. So this is 30 plus tangent plus theta, 30 plus this one is I put it theta 1, okay, you will get the answer for the BAF angle, okay. So if you are trying to find the D, you have to use this equation, okay. It is a trigo as well, okay, it is trigo as well, okay, all right. So you will get D 0.496, okay. Once you have D, you can use the general equation, which is the definition of moment, mb equal to fd, okay. So substitute f into the equation, substitute d into equation, you will get the final answer of moment of force about point B, okay, right. So just now your friend said that the answer should be negative. Yes, agree with you. But in this what do you call it, in this example, okay, the final answer already state the clockwise. So if you already state clockwise, no need to put the what do you call it, the sign negative, okay. If you put if you not putting the CW, you have to put the negative value there. Like
Doctor,
this.
I don't know how to state if it's counter.
Oh wait, again, I cannot hear you.
How to identify? How to say that it's counterclockwise or anti-counterclockwise?
Great question. Great. I like this. So the answer is like this. Okay, the answer. Okay, you have this point. Let me change the color. Okay, you have this point E and B. Okay, E and B, and the forces acting on A. Okay, the forces acting on A. Okay, I have to. Yeah, the example. Okay, the example. How to make it like this? Maybe. Or maybe like this. Or maybe like this. Or maybe like this. Okay, like this. Okay. So this is example. Because my camera is mirror lah, I cannot imagine how to explain. Maybe like this. Maybe like this. Okay, like this. Okay, like this. Okay. So I have to mirror my mind as well because my camera is mirroring. Okay, so this is the rigid body in example 1. So we do have point point B here, point A. Okay, point B, point A. Okay, so the forces acting like this. The forces, is it mirroring, or should I explain like this?
No, Doctor, the previous, yeah, this is correct.
Yes,
Okay. Because if I see at the camera, this is not the correct way. I mean, in front of me is not correct way. Okay, let me explain again using this one. Okay, if you look at the camera, okay, camera, this is the thing that you will look at the example 1, rigid body. Okay, so point B, point A, point B, point A. Okay, point B, point A. So the force is at point A here. The force is at point A. So the direction of force, the direction of force should be I confusing because the physical thing should be not like this. Okay, so it's mirroring. Let me think about the mirror situation. If you are in physics in class, I can explain because it is physical. Okay.
Doctor, for us, I think
Okay,
it's correct, but
so now I have to mirror my mind. I have to opposite thinking. Okay, your force is like this, is it? Okay, your force is like this. Okay, your force. Okay, basically, if you have this force, okay, if you have this force at this direction, okay, this direction, this is your force, 1000 Newton. We are trying to pulling this rigid body. Let's say I'm pulling this rigid body. So with B point is rigid, meaning that we fix at this point B. Okay, if you are pulling at point A like this, okay, this rigid body, this L-shaped rigid body will be rotate like this. Okay, so let's say I fix it at this position of B. Okay, so I have a force, okay, like this. So your rigid body will be moving like this. Can you imagine? So if
yes,
you look
Doctor,
at the
yeah,
camera right now, the rigid body is moving clockwise. Okay, the rigid body is moving clockwise. So in front of me, the rigid body in front of me, without seeing at the camera, the body is moving counterclockwise. But in front of you in the camera, the body is moving clockwise like this. Can you see it?
right, Doctor. Yeah.
Okay. Right. So your force like this. Okay, your force like this. We are trying to pull the rigid body, pulling like this with a fixed point at, because we are trying to find the moment about point B. Okay, so the rigid body will be moved like this. So that's why we get the clockwise direction. Okay, do you get it? Do you get it?
Yes, Doctor.
Yeah.
Thank you,
All
Doctor.
right. So another explanation, maybe I can explain in this slide. Okay, so you have this B point. We are trying to find moment B. Okay, meaning that we have to fix at this point. Okay, we assume that the body is moving. In static, we cannot say that the body is moving, but to imagine that where is the location, where is the rotation side, so we have to assume this rigid body is moving. So we have this force. Okay, if you fix at this point of B, this rigid body will be moved like this. Okay, meaning that it is clockwise. Okay, if the force acting like this, for example, okay, like this, for example, the direction should be what? Yeah, correct. Anti-clockwise, counterclockwise, CCW. Okay, great. So you will go through many exercises, then you will understand the sign, positive and negative, also the direction of the rotation. Okay, so this is the thing that if you use definition of moment, okay, the second question from this example, you have to resolve it into the components, into its components. Okay, all right. So the second one, the thing that you will use Verdun theorem, okay, you have to resolve the force into two components first. Okay, like I explained just now in the previous slide. Okay, so we do have F here, F equal to 1000 Newton. Okay, so you have to resolve into X component and also Y component as shown in the slide. Okay, all right. So the angle is given there, 30 degree. Okay, you have this value of Fx equal to 866 Newton, and then Fy 500 Newton. Okay, this one more straightforward. Okay, no need to use trigonometry. I mean, no need to use a triangle that have many unknowns. Okay, they have many unknowns, but this one we do have many knowns. We just use known that available from the picture. Okay, so I suggest you to use this method in solving the moment. Okay, so using the if definition, okay, definition. So you have the two components. Okay, this one is component y component, and this one is x component. Okay, substitute both of them, you will get the similar answer like before. Okay, all right. So on how to determine the d is actually, as I explained just now in the previous slide, this d is belong to this line of action. Okay, which is okay, and this line of action for y component, the d should be like this. Okay, must be perpendicular. Yeah, this one should be perpendicular. Perpendicular. So D is 0.3. Okay, D is 0.3. This 0.3, and the y component of F is 1000 sine 30. So this is the way that you can get this the answer very quickly. Okay, so any question for now? Okay, if no, I proceed to the next one. Okay, example two. Okay, are you okay if we proceed? Okay, so this is the example two. Okay, the example is straightforward. To get the d, for example, to get the distance from the line of action to the point. Okay, but this one is maybe very tricky. Okay, but in the end of the day, the easiest way that I just said to you is the Vernon theorem. Okay, this is that the thing that we not doing a lot of mistake. Okay, so example two. Determine the moment of 1000 Newton force about point B by resolving the force into its component and use the result to find the shorter distance between the line of force and point B. Okay, so this is another type of question. So the first thing, you have to find the moment. The second tip, from the moment, okay, moment is the moment, you have to resolve it. Let's say I put it component x plus component y. Okay, all right. So from here you have to find the second one. This one, the second one. Use the result to find the shorter distance. Shorter distance meaning that d between the line of action and point B. Okay, so this is the line of action. Okay, this is the line of action. Okay, my question is, where is the shortest distance? Where is the shortest
Perpendicular.
distance? From where? From where to where?
Doctor, is it from B to the line of reaction?
Yes, correct. So the shortest distance is between the line of A force and point B. Okay, this is the line of force. So already mentioned there, the short distance between the line of force, this line of force, and this point B. Okay, all right. Let me change the color of pen. Okay, so from point B, there are many lines can be drawn from B to line of force, like this, like that. Okay, so the shorter distance must be perpendicular, this one lah. Okay, from B to line of action, the shorter distance. If you look at this line, is longer than the first one, the shortest one. Okay, if you look at this line, it's not a shortest distance. Okay, and the shortest distance should be perpendicular. Okay, from the line of action to the point of B. Okay, this is the shorter distance. So you have to keep in your mind what is the shorter distance from where to where. Okay, the shortest distance should be perpendicular. Okay, so this is the thing that you have to find D. Okay, basically, okay, you have to find D from, the idea is you have to find D from the value of moment that you calculated earlier. Let's say the moment here, for example, the moment is 100 Newton meter. So from here, you will have the definition, the moment definition equation to find the D, the shorter distance. 100 F or the given 1000, for example. This is only example. The 100 Newton meter is example to give idea to you. Okay, you will get D like this, shorter distance. Okay, right. So let's move to the solution. Okay, if you want to find the moment using the Van Allen theorem, is very straightforward. Okay, you have to resolve the force into x component. Okay, let's say this one is cos 30, this one is 1000 sine 30. Okay, from here you have to determine the distance. Okay, the distance. Let me check. Let me select the other color. Okay, the distance. This is the line of action for x component. This is the line. This is the line of action for y component. Okay, so the point that we are calculating is point B. The distance, okay, should be perpendicular. This is the distance. Okay, and the distance for y component is this one. This is the distance, must be perpendicular. Let's say I put it dx, and d is the dy. Okay, all right. So at the end of the day, you will calculate moment. 1000, yes, 1000 cos 30, and the distance is dy. Okay, dy is 0.3. Okay, and then you have to bear in mind about the sign, meaning that where is the negative, where is positive. For this case, should be negative. Okay, and the y component should be positive. Okay, I will explain why we get negative and why we get positive. Sine 30, the distance should be 0.4. Okay, you will get the answer of moment about point B. Okay, right. Okay, so my question is why the x component is negative? Do you get it? Anyone?
No, doctor.
No, doctor. Anyone? So if you look at the solution, okay, solution similar lah, like what I write just now. Okay, so the negative is for the x component. Okay, similar. Negative 1000 cos 30 times with 0.3. Okay, and the y component is this one, 1000 sine 30, 0.4 positive. Okay, and the answer is this one. Okay. All right. So again, my question is why we get the component of x in negative sign? Why? Why? Anyone? 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 Come on, guys. Why?
Doctor,
Someone,
there's someone answer in the chat box.
someone answer. Maybe you can unmute and say something because I cannot see the chat.
Wong said because dy is negative.
No, it's not related to the distance. It should be relating the movement. I give you 1 minute to think. I give you 1 minute to think. Why we get x component in negative sign? 1 minute, 1 minute. One minute. Why negative sign? Anyone? Okay, there is one answer from the chat box from CBE. So mention that cos 1000 cos 30 makes B become counterclockwise. Yes, correct. The answer is correct. Okay, because of the forces for the x component. Okay, and we fix at the B point, the rigid body will be moved counterclockwise. Okay, so do you get idea from the explanation from your friend? Guys, yeah, I will explain again. So but my question, do you get what the idea from your friend?
Yes, doctor.
Yes, can you explain to me?
Just like she said, because of the forces acting on A, it causes the body to move counterclockwise at point B.
Yeah. Correct. So that one is correct. Let me explain. Let me draw why this happened. Okay, let me draw why this thing happened. So erase everything. Okay, I choose pen, bright color. Okay, so you have this component fs. You have this component fy. Okay, if you look at this thing, you have to find a moment about p, meaning that you have to fix at b point. This one is should be fixed. And this rigid body of L shape should be rotating. Okay, should be rotate. Okay, and then if you look at fx, okay, this rigid body, if you fix at this one, this rigid body will be moving like this. Okay, let me draw another body. Okay, so if you pulling point A, okay, along the x component, the rigid body will be moved like this. Okay, the green color is the rotated body. Okay, so you can see that the rigid body is trying to moving counterclockwise. Okay, counterclockwise. Okay, do you get it? Do you get it? Senyap ke ni? Okay. So the question from the chat box. CCW should be negative. It is based on your definition. Okay. Based on your definition. So normally for me, the counterclockwise, I define negative. The clockwise, I define positive. Okay. It is not similar like I just show you in the slide, which is in this slide. Where is the slide? Where is the slide? Yeah, this one. Okay. This is the direction that I just told you right now. Just told you just now. Okay. This is the definition. But somehow you can define the other way. It's depend on you. Okay. Similar like as this. Similar like as this, like this. Okay. Similar like as this. So I define this one is positive. If I want to define this negative, it is okay. It is depend on you. It depend on you. You can define this one negative. This one direction is negative. It is depend on you. So basically, for me, I define this one is positive. This one is positive. Okay, with this direction. Okay. Similar goes to the rotation part. Okay, I define counterclockwise in negative. I define clockwise is positive. Okay. If you define this one positive, this one negative, you will get the similar answer later on. Okay, you have to try it. You have to try by your own. Okay, you can define whatever you want, but the definition in the beginning should be similar, should be same throughout the solution. Okay, so in this case, we're defining counterclockwise is negative, clockwise is positive. Okay, so if this force Fx acting on A, okay, the rigid body will be rotating counterclockwise. So by definition, we assume definition, our own definition is negative value. Okay, so do you get it? Okay, so for the second component, let me explain more. Okay, for the second component, Fy, okay, Fy, of course, this one, this rigid body will be rotate like this, clockwise. So our definition just now is clockwise positive. Okay, our definition. So if you draw the body fixed at point B, the body will be rotated like this. Okay, because of the forces of Fy. Okay, from the original here, AB rigid body will be moving like this. That's why we get positive. Okay, all right, clear? Do you clear?
Yes, Doctor.
Right, great. Oh, power. Okay, so if you have problem, if you go through the exercise, you will get the idea on how to get positive and negative value. Okay. All right. So yes, of course. Okay, of course, you will get this answer. Okay. Okay. In my case, if you already put a negative sign, this one, okay, no need to put CW anymore. I will understand the situation. Okay, it just depends. If you want to put both negative and also the CW, it is okay as well. Okay, this one is for me. Okay, let me erase. Okay. If you have question, maybe you can just voice out. No need to type, because I don't open chat box every time, because it's difficult to see the chat box. Any question?
The test one, Doctor, it will be before the momentum, yeah?
Sorry, is it question from Daniel?
No, Doctor, it's from Abdurrahman.
What is the question?
The test one, it will be until
The
here?
test one is not in our syllabus yet. I will cover the syllabus, then we will discuss about the test.
Okay,
Okay.
thanks. Okay, thanks.
because we are not enough time to have that discussion. Maybe you can discuss in the WhatsApp group. Okay, so Daniel asked about the direction. If we define for our own direction, we need to put notice in the first place. Yes, correct. Or just to the correct final. You have to put the first place. You have to define it in the beginning. Okay. Okay. Other question? Is there any other question? Okay, if no question, I just proceed. Okay, example, still in example 2. Still in example 2. Okay, so you have moment. Okay, moment with two different type of answer. Okay, right. So if you put negative, okay, I can know that that one is clockwise. If you put positive, I can know it counterclockwise. Okay. Right. So the second question is about this one. Okay. Sorry. This one. You have to find the shortest distance between the line of force and point B, which is this thing. Okay. This D. You have to find this D. So it is straight away you will have to use the definition. Okay. This is the thing that you will use. Okay. This thing. The definition. You already calculated the moment. Okay. Previously. And then we do have force, and then we have to calculate D. So put everything, put known value into the equation, then you will get straight away the distance, the perpendicular distance. Okay. So make sure that the moment you choose is positive because the distance is scalar product, and there is no negative value for distance. So your distance should be always positive. Okay.
Okay, doctor.
Okay, if no question, just proceed to the next slide. Okay. Okay. Next slide. It is about the principle of transmissibility. Okay. So what this principle means that the moment of a force about a point is the same as long as the force lies on its line of action. Do you get what is this?
Yes, doctor.
What does it mean? Hmm?
The moment along the same line, it's the same value.
The moment, is it?
Yes, along the same line.
Yeah.
Right.
So let's say you have this rigid body, for example, like this. Okay. Right. So your force is from here, for example, this one. Let's say I put it here. Oops. And this another point, P. Okay. So from here you can calculate moment. From here you can calculate a moment of a force about point B. Okay. The meaning of this principle is actually the moment of force about point. Let's say point B here. Okay. In this situation, point B is the same as long as the force line on its action of action lies on its line of action. So this is the line of action. This is the line of action. Oops. Oops. Okay. No matter the force acting on A, or let's say I put it this point C, or let's say I put it D, or I put it E here, or maybe here F. Okay. as long as the force, as long as the point, as long as the lines of action, okay, similar with this line, okay, the moment B will be always similar. Okay, will be same. This is the meaning of this principle. Okay, do you get it?
Yes, doctor.
Because of what? Because of this distance. Make sure that the force, this force, let's say force A, I put it force A, 100. Force D, 100 as well. Force E, 100. As long as the force is similar as well, then you will get the answer for moment is similar. Okay, right. If you don't trust me, then we do this example. Okay, do this example. Okay, all right. So I think I should give this to you to solve it now. Okay, can you do it now? Can you do it now?
Can,
Please
doctor.
do it now. Yeah, please do now. I give you 5 minutes. 5 minutes to solve this problem. Okay, example 3. You have to determine only moments about point O. Okay, all right. So let me illustrate. Let's say for the first question, the moment is sorry, the force is like this. Okay, A. This one, the force is at B. Okay, and this is point O, point O, point O. And this one is a moment where is the force is from C. Like this, C, O. Okay, try. You have to try right now. Can you try it? Please try. In 5 minutes, 4 minutes left.
The point A is minus 50.
Sorry, are you saying something?
The point A, the momentum is negative 50 or
The answer. Okay, what do you get? The
negative
moment.
50.
Sorry, maybe you can speak louder, please.
negative 50, doctor. I get negative 50.
Negative 50. This one.
Yes, doctor.
Okay. So to everyone, is it you get the similar answer? Do you get a similar answer?
Doctor, I get 1,400.
Okay, 1,400 Newton meter. Okay, what about others? What about others? Others. You get the same answer or not? Or not? Or not? Hmm? Anyone? Anyone? Okay, let me. I think I have to call someone lah. If correct like this. Let me check the name. I know. What is your answer?
Yes, sir. Can you give me 1 more minute? I'm still calculating.
Okay. Stick. Daniel, your answer, please. Daniel. Still calculating. Junai, your answer, please.
Is it 599.86?
Your answer is 5?
99.86.
99? 599? 599?
Yes, 0.86.
Okay, this answer from Junai. There are various answer. Okay.
Hello, doctor.
Yeah,
I also got 140.
140. Okay, 2% said 140. How about others? Don't feel shy because we cannot see your face. You can see your answer here. We are discussing. We are discussing. If you got wrong answer, no need to shy. This is the learning process. We are learning together. Hmm. 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 And,
Doctor, sorry, I got the wrong answer.
which one? The red color, is it?
Yes, sir.
The wrong answer. Okay.
It's 239.94.
Different pula.
Yeah.
How much?
239.94.
239.94. Oops. Where's my charger? Charger. So, what happened to others? Are you still live? Or already dead?
Still calculating, doctor.
Oh, still calculating. I thought already dead. Okay. Why? Okay. Why? Okay. FY. Any other answer? Extra 1 minute. I know Shahada get, sorry. Maybe you can say difficult for me to open chat box. Close chop. Close open, close open.
Doctor,
Yeah.
I get different answer. I get negative 200.
Okay. 200 centimeter. So many there are many answer from you guys. Okay, let me check. So this is the thing that I do right now. Okay. I resolve into x and y components. You will get fy 1000 in bracket 0.3 over 0.5, fx equal to 1000 in bracket 0.4 over 0.5. Okay, this is the components x and component y. Okay, so if a moment, okay, if moment about point O, okay, if you are looking at a force at A, okay, so the fy y component, okay, should be negative. Okay. Okay. And the x component is positive. And if you look at this thing, okay, if you look at this thing, you will have to know that x component is no longer exists for the moment. This one is 0. This one is 0. So the only thing is left. The only left is x component. Y component. Okay. So the y component, okay, negative 1000, 0.3, 0.5 time with distance 0.4. Okay, your answer is oops. Okay, and this is the answer. Let me calculate. Where is my calculator? Okay, this 1000 times 0.3 over 0.4 times 0.8. The answer is 200 negative, 240 Newton meter.
Doctor, this point A.
Sorry?
Which point?
Can you speak louder? I cannot hear you.
This which point, Doctor?
Sorry again?
Which point, A or B or C?
This
This
one is for A, point A.
Okay.
Okay. Do you get similar answer like me?
Yes, Doctor.
So your answer, this one only one. Junaid, is it? You got the same answer like me, but yeah, of course you are using angle. I'm using the distance. Okay. This one is wrong lah. Wrong, okay. The answer is 240 Newton meter in negative value. Okay, in negative value, because I assuming the counterclockwise is negative. Okay, you can put if you want to put like this. Wait, if you want to put like this, I also accept the answer. Okay, no need to put CW, CCW. Okay, if you want to put both, then I also accept the answer. Okay, yeah, again, if you have question, please switch on the mic and say. Any question?
Doctor, can
Yeah.
I ask why, can you explain again why the mx is 0?
Good question. Okay, good question. Okay, let me erase this all. Okay, choose pen. Okay, choose color. Okay, all right. So we do have two different components, and then we have to refer the point that we are calculating, which is point O. Okay, about point O. You are calculating moment about point O. Okay, so you have to understand the distance. The distance must be perpendicular to the line of action, from the line of action to the point. Okay, D, the definition of D. Okay, distance, perpendicular distance. Distance, okay, between line of action to the point. This is the definition. Perpendicular distance. Make sure that perpendicular distance. Okay, let me draw line of action. This is your line of action for X component. Okay, can you see where is the D? If you compare, if you draw from O, can you see it?
No, doctor.
Yeah, the answer no. It means that there is no perpendicular distance, okay, from line of action to the from the line of action to the point O. So that's why the X component is 0. Do you get?
Okay, doctor, clear.
Okay, so if you look at Y component here, Y component is line of action. Now the dot line is line of action. Okay, you can see the perpendicular. This is the, let me erase this thing first. Okay, and okay, this is line of action for Fy. Okay, and the distance from 0, from O to the line of action, this is the perpendicular distance, D, perpendicular, perpendicular. So for Y component, we do have perpendicular distance. But for X component, there is no perpendicular distance, meaning that the D is 0. That's why the previous my writing, I put it mx equal to 0. Okay, do you get it?
Yes, doctor.
Correct. Correct. Okay, I keep to you. I leave to you to solve the second one, which is at B. Which is at C. Sorry. Okay, I leave to you to solve the C. Okay, the C one. Okay, let's begin to solve this problem B. Okay, you can you start now? 5 minutes. 5 minutes only. Okay, 5 minutes. Five minutes. 5 minutes. Okay, what is the answer? Any answer? Yeah, Junaid said minus 240 Newton meter. This one is correct. Okay, the answer is minus 240 Newton meter. It is similar like before. Okay, this one example showing you the principle of transmissibility. Okay, this example 3 is explaining, is showing you, okay, the principle of transmissibility. Okay, so everyone got the answer? Do you get the answer? Guys, do you get the answer?
Yes, doctor.
Yes. So which component is 0?
Why, doctor?
For this,
Why?
yes, correct. Yes, for this case, the component 0 is y. This is equal to 0 because there is no perpendicular distance to the O. Okay, this should be 0. The moment 0, not the force. The force we do have value, but the moment is 0 because D is equal to 0. Okay, so we do have only Fx and the D. Okay, the D is 0.3. 0.3. So you will get the answer, similar answer, moment. If you put the force at point B, the moment will be similar, minus 240 Newton meter. So make sure in your final answer, you put the direction, you put the value, and also you put the unit, okay, units. So if I found there is no unit in your answer sheet, I will deduct your mark, okay. So this is the thing that you have to put. All right. Okay, can I proceed to the next?
C is it negative 200?
Sorry, Abdul Rahman, can you speak louder, please?
Sorry, doctor. Point C is it 200? Negative 200?
No, the answer for all cases should be negative 240 Newton meter, should be similar. Okay, for C, let me explain about point C. So point C, the component of X and Y, having values, there is no zero component. Okay, sorry, there is no zero value for the components. Okay, because the distance, the perpendicular distance is there. Okay, the perpendicular distance, this one. Okay, the perpendicular distance is line of action. Okay, this one, perpendicular, d y dx, for example. And of course, you have to find the s dy using what do you call it, using trigonometry. Okay, all right, the answer for all cases should be similar. This explaining about the principle of transmissibility. Okay, you have to try it. You have to try. I will not explain in this lecture. You have to try by your own. Okay, if no question, is there any question?
No, doctor.
All right, no question. Okay, if no question, okay, I provide you some exercise. Okay, I provide you some exercise. Okay, so there are 3 exercises. Okay, the answer is there. The answer is there. You can do it by your own first. Okay, you can do it by your own first. Okay, so if any question, if any problem that related to exercise, you may WhatsApp me. Okay, to ask the question. Okay, this is very straightforward. Exercise is very straightforward. Exercise 2. Okay, for exercise 2, we do have 2 forces. Okay, so you have to consider all forces to calculate moment. Okay, the previous example like this, okay, we only have one force. Okay, we only have one force, but exercise 2, we do have 2 forces. Okay, and the exercise 2, sorry, the exercise 2, okay, you have to find a moment of force about point C here. So you have to consider 2 forces. Okay, right. And the last one is this one. Okay, this one is also involve two forces. Okay, with different with same value of force, 50 Newton, but different position of force. Okay, you have to consider both of them to calculate moment. Okay, right. So I leave it to you to do the exercise. If any question, you can just let me know. Okay, boleh tak?
Okay, doctor.
Right.
Okay, doctor.
Okay.
Thank you.
Okay, I think that's all for today. If no any other question, I think that's all for today. The lecture note and the recorded video will be uploaded later. Okay, you can refer the lecture note. Okay, regarding the tutorial, we be begin on
Thursday.
this coming day. Sunday lah. Sunday ke Thursday?
Sunday or Thursday?
Sunday. Hey, you not refer the WhatsApp group ah?
Sunday 9 a.m.
Yeah, Sunday. It should be Sunday. So better refer back to the WhatsApp group Sunday 9 a.m. Okay, before the tutorial class, I will give you some question, okay, to be answered. And during the tutorial class, we will together discussing about the answer and solution. Okay, so you have to prepare your answer first. Then we can discuss during the tutorial. Is it okay like that?
Okay, doctor.
All right. So I will upload the question in the e-learning later on for the tutorial class. Okay, for the coming Sunday tutorial class, it is maybe it will based on the lecture 2, lecture 2 or lecture 3. Okay, so we are covering about the test 1 as well. Okay, right. So far, any question before I left? No question.
Sir, I messaged you about my attendance. Can you please excuse me?
Why now? Hassan, is it?
Yes, sir.
You just joined or what?
No, sir. I joined at 4:26, I think.
Okay. All right. Okay. So let me remind you again, everyone, not only Hassan, but everyone of you. Okay. So the attendance will be recorded only for the first 10 minutes. Okay. If you join late, you can join the class, but the attendance will not be recorded. Okay.
Sir, please excuse
So
me
I think that's all.
for one day.
Okay.
Sir.
So I think that's it for today. So let's, yeah. If you have any question, you just let me know and we can
Doctor,
discuss together. Yeah.
some people as Ahsan live in Saudi. The time there is 4 o'clock a.m. 4 a.m. there. So that's
Okay.
will be difficult.
Okay, understand. So I will record manually later on.
Thank you, sir. Thank you very much.
Doctor.
Okay. So if no question, just we end the class right now. Okay, we end class right now. Thank you so very much. See you next class on Wednesday. Okay. And happy Mubarak. Happy Eid Mubarak.
Ramadan Mubarak.
Thank you, doctor. Thank you, doctor.